Okay, now we're going to convert polar coordinates. So when you have the radius and the theta, we're going to convert it to rectangular, a point that would show up on just a coordinate graph. This is how you find the x. You just multiply the r times the cosine of the theta. And to find the y, you multiply the r times the sine of the theta. And that's it. So let's do an example. So right here we have x is equal to r times the cosine of theta, y is equal to r sine theta. Well, if you've got a theta that's on the unit circle, you could just look at your unit circle, and at 135 degrees, you'll notice that the x value is negative root 2 over 2, and the y value, or the sine, remember, the x is the cosine. Think about alphabetical. X, y is alphabetical. Cosine, sine is alphabetical. So now when we want to find the x value, it's the radius times the cosine of theta. But since 135 degrees, the cosine of that theta is negative root 2 over 2. So x will be negative 3 root 2 over 2. And for the y value, well, notice those are almost the same. Root 2 over 2, root 2 over 2, one's negative, one's positive. So the y, we can just save a step. This will just be positive 3 root 2 over 2. And then when you put that back in xy, we have that x is negative 3 root 2 over 2, and the y is positive 3 root 2 over 2. So on the xy plane, it would be in the same location. Okay, and I think, let's see. Yeah, if it's in radians, same thing here. Let me cover all this stuff up. Notice we're going to be in the first quadrant because those are both positive. And at pi fourths, you've got positive root 2 over 2 for the cosine, positive root 2 over 2 for the sine. So x is equal to 3 positive root 2 over 2, because that's cosine theta. And y is equal to 3 times root 2 over 2, because remember, root 2 over 2 is sine theta. So, and I made these similar on purpose. I just wanted to show you angles that are similar. These are both 45-degree angles. This is in the second quadrant. But that process, regardless of the quadrant, is the same. And this is converting polar coordinates back to rectangular x and y. So you start off with r theta and you convert back to xy, and this is the process. To find x, you multiply the r times cosine of the theta, and y is equal to r times the sine of theta. Make sure you're paying attention to the quadrant, so in case you have to graph it, your graph makes sense. All right, that's it for this one.